So we are given this function and we are assigned to find the derivative of it. So we can start off by identifying what kind of functions make up this graph. So on this side we can see is a cubic, and the derivative of a cubic will be a quadratic, so we'll know there will be a quadratic function in there. And we have a linear function right here, and we know that the derivative of a linear slope will be a constant. So now we can identify any key points of interest to make this easier. So we can see that there is a maximum right here and a minimum right here. So we can mark those on the x-axis. And we can see a cusp at this point, which we'll get to later. But beginning left to right, we can see that the function is increasing as it approaches this max. So we will know that our quadratic function will be positive on the positive side of the x-axis until this point. So we can draw that in. And at this maximum, it becomes negative, so that means we will go below the x-axis as it is negative. And we can account for the other minimum right here, knowing that once it reaches the minimum, it again becomes positive, like so. And once we reach this point, this is the cusp. We can see that there is no tangent line. It can go that way, so we have it that way and that way. So there's no one tangent line. So we'll mark this with an open circle. And where this open circle goes, we have to look at our linear portion of the function. And we can identify that the slope of this line is -1, rise over run. It's -1, so we'll go to -1, label the open circle. And the derivative of a linear function is a constant, so it will stay at -1. And it should look something like that.